We're going to be taking a look at interpreting derivative graphs in this video. And so the graph of f prime is given right here. And so what we're going to look at then is going to be on what intervals is f increasing and what intervals is f decreasing on this. And so to interpret where f is increasing, we need to think about what's happening to the original function. So let me just sketch an original function over here. And let's think about our derivatives, which are the slopes of your tangent lines at different places. Okay, so if you think about a function that is increasing, when a function is increasing, that means the slope of your tangent lines are going to be positive slopes because your tangent lines are going to look like this, going up from left to right. When your function is decreasing, that means your tangent lines are going to have a negative slope, or in other words, the derivative will be negative. And then when you have a maximum or a minimum, your tangent line is going to have a slope of 0. Now, one of the other things that we'll take note of here is that if your graph is curved like this, then what's happening is the tangent lines are going to change from a negative slope to 0 and then to a positive slope. So when you have a minimum on your graph, your derivative is going to have to change from a negative value to a positive value. And when you have a maximum, your derivatives are going to change from a positive value to a negative value. All right, so on this particular graph right here, it says on what intervals is f of x increasing. This is the graph of the derivative. The original function is increasing when the slopes of the tangent lines are positive. So in other words, when your derivative is positive. So if we just highlight the areas where your derivative is positive, that would be in those areas. So let's just call this negative 1.5, and we're going to call this negative 3.5. And so your function would be increasing between negative infinity, because we're assuming this goes on forever in both directions. So negative infinity to negative 3.5 union negative 1.5 to 1. Those are the red regions on this particular graph. All right, so now we're going to look at where is our function going to be decreasing. Our function is decreasing when the slopes of the tangent lines are negative, which means your derivatives are negative. So your derivative is negative in this region here and in this region right over here where it's blue. Okay. So now it also asks us to explain how we know that. All right, so on the first one, we would say f of x is increasing on this interval, and then we would state because f prime is greater than 0, which means your derivatives are positive. The intervals where our function is decreasing are going to be from negative 3.5 to negative 1.5 union 1 to 6. And we know that because f prime is less than 0, which means your derivatives are negative. All right, so the next thing it's going to ask us to do is determine any relative extrema. Extrema are going to be your maxes and your minimums, maximums and minimums. And it asks us to justify our reasoning. How do we know this is a maximum? How do we know there is a minimum? And so if you go back to this graph over here, you have a maximum when your derivative changes from a positive value to a negative value. And you have a minimum when your derivative changes from a negative value to a positive value, because slopes are changing from negative slopes to positive slopes. All right, so looking at our graph, maximums and minimums will always occur when your derivative is 0. So that is here, here, and here. All right, so here at this first place, our derivatives are changing from a positive value to a negative value. Well, that means it's a maximum, just like this one right here, changing from positive to negative. So we are going to have a max at x equals negative 3.5. We also will have a maximum at x equals 1 right here for the same reason, which is because f prime changes from positive to negative. And that's what happens with our maximums. Our derivative changes from positive values to negative values. Slopes are positive to the left, negative to the right. All right, so now the minimums. The minimums are going to occur, or the minimum is going to occur right here at negative 1.5. And the reason is because f prime changes from a negative value to a positive value. Now over here, we cannot say for sure that this is a maximum or a minimum, because we really don't know what happens to the right of 6. We can make a guess that it might be going up, but it could be a piecewise function that looks like this also, and may not have a derivative at that point. So we cannot assume anything in that regard. All right, so we definitely have maximums and minimums at these locations. All right, so let's go on to the next graph. Similar situation here. We're going to be determining the maximums and minimums. And so this says find where f is increasing. And so f is going to be increasing anywhere that your derivative is positive. And your derivative is positive here and over here. So your function would be increasing from negative infinity to negative 2 and from 0 to 2. And the reasoning is because f prime is greater than 0. And your function would be decreasing in the blue area. Here, oops, let me back up for just a second. 0 to 2 is not completely correct. I did not catch that right away. this would actually be from 0 to infinity, because all of that is equal to or above that. And so this is because f prime is positive. And then decreasing on the interval where it's negative, and that is going to be in this location here, which is from -2 to 0, and the reasoning is because f prime is less than 0. Next thing it says to find is our maximums and minimums. All right, so we have a max right here, and the reason there is a max at x equals -2 is because f prime changes from positive to negative. And then we are going to have a minimum right here, and that is at x equals 0, and that's because f prime changes from negative to positive. Now, right here, our derivative is 0. However, it's not going to be a maximum or a minimum because our function would be increasing to the left and increasing to the right. The type of function that would give you that situation would be something like a cubic graph, where the tangent line in the middle is horizontal, but it's increasing to the left and increasing to the right. So you have positive slope, 0, and then positive slope again. All right, so then the part C here says if f of -3 is equal to 2, sketch a possible graph of f on the same axes. All right, so with this, let me take a second to erase a few things, and I'll get back with you in just a second. Okay, I went ahead and took the liberty to go ahead and sketch a graph while I was out, and what we've got here, we want to look for some specific points. Right here we know we have to have a maximum because our f prime changes from positive to negative, so we had a maximum here. We're starting out at -3, 2, which is right here, so we have to increase, and then we're going to be decreasing all the way down to x is 0, and we're decreasing for that whole duration because f prime is negative. Then we reach a minimum right here because f prime changes from negative to positive, and then we're increasing, so we increase here. When x is 2, we have a horizontal tangent, so our derivative is 0, but then our function is increasing again to the right of that. Here we're going to be taking a look at some matching situations and trying to determine what the derivative graph would look like based upon the original. And so on the original for number 1, what we know about this is that our slope is the same value everywhere. It's a linear graph, so that means its slope is the same. It's increasing, which means our derivative is going to be a positive constant value. Well, the graph that has a positive constant value is graph B. All right, so graph 2, if you think about what's happening with our function. Right here, you are going to have a slope of 0. So your derivative is going to be 0 at that point. To the left, our function is increasing, so we're going to have a positive value for our derivative. To the right, our function is decreasing, so our derivative will be negative. So our derivative is going to be positive, 0, and then negative. All right, well, the graph that does that is going to be graph D. We have a positive derivative, 0 derivative, and a negative derivative. All right, so looking at graph number 3, this is a graph of an absolute value function. One of the things you'll notice is to the left of 0, this is acting as a linear function. The slope is the same everywhere to the left of 0, and is decreasing from the left to the right. Since it is decreasing from the left to the right, our slope or derivative is a negative constant value. To the right, our derivative is a constant positive value. So we have a constant negative, a constant positive, and then at this point right here, the derivative does not exist because we have a corner. So the graph that fits this category is graph A. We have a constant value, constant negative value to the left, constant positive value to the right, and because of these open circles here, that indicates that the derivative does not exist at those points. All right, so looking at the next one, we have a constant positive slope, and to the right we have a constant positive slope. So and because the lines are parallel, the slopes are the same. It's the same constant. Now the other thing is, at x equals 0, we have a discontinuity, which means the derivative will not exist at x equals 0. So positive derivative, same positive derivative, derivative does not exist. That would match with graph F. All right, number 5, analyzing. You have a positive derivative here because we are increasing. At x equals 0, there's a horizontal tangent, so the graph is 0, or the derivative is 0. To the right, the derivative is positive. So we have positive, 0, and then positive again. So the graph that matches that is going to be graph C. And then that leaves us with graph E going to this one. And one of the main things we can look at is right here. We have a sharp turn or a corner. Therefore, the derivative does not exist. And we can see that on the derivative graph does not exist at x equals 0. We have a constant positive derivative to the left, which is this. And then our slope to the right is going to be this one right here. All right, so we have a summary here of just some things to pay attention to. Anytime your derivative is positive, which means greater than 0, your function is going to be increasing. Whenever your derivative is negative, your function is decreasing. In order to get a local minimum, y prime will change from negative to positive. To get a local maximum, y prime will change from positive to negative. All right, these other 3 terms or properties we'll talk about later. These have to deal with concavity, and we will talk more about that when we get to our second derivatives. And this is just a pictorial summary or graphical summary of what we have just gone through. And if you want to just pause this, you can look at it and study it in reference to the notes that we had on the previous slide. All right, so now it is time for you to practice your graphs of derivative functions.